All right, continuing onward, what do we do next? Well, we need to create these functions. And how do we go about creating these functions? So if we go back to the original problem, right? They say use a hash map and vectors and create a text interface to allow a user to blah, 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 blah. The text interface we kind of created already. We haven't done anything with hash maps or vectors. One thing to note about the text interface is that this text interface can add multiple people. So we did in the first line, let's say we did add Sally to engineering. And then the next one we did add Amir to sales. What does that tell us about our hash map, our data structures that we're using? To me, what it tells us, at least in this structure, is that our data structures are being passed in and saved again, as in the state is changing and can change multiple times. So what I'm trying to say is our function is going to have access to our hash map, but outside of that function, the data in that hash map still has to exist. Because if we add something and then do a show, the show and the add have to have access to the same hash map. And if that is the case, then that needs to be in main. Let's create our map. Make it mutable because things are going to be changing with it and we're adding things to it. Not taking anything out, but we're adding things to it. Mutable map, and we're going to set it equal to hash map dot new, and that's already set there. And collections hash map just already got. Okay, cool, that works. Now we need to do our functions. Let's do the add function first. Function add to department. We're going to take in the hash map. So we're going to take in our map. We currently don't know the signature for this map. Okay. So each department is going to have a name. And associated with that name is going to be a list or a vector of names. So we have our key, which is going to be the department. And then our key is going to point to a value, and that value is going to be a vector, and that vector is going to be of strings because those in the vector is going to be names. So in terms of our hash map, I believe it's hash map string. We have vector. I'm not sure if I'm writing this correctly. You know what? An easy way to figure this out is just to pass in a vector into this thing. Let's say hash map new map dot entry testing. I kind of want it to be a string, say a toString. Dot insert or and make it a vector and give it a testing and make that a toString. Does it have to be a toString? I guess it doesn't really have to be, but does it have to be? We'll call it a toString. So now we can see an example of what the type of this map is. So let's write that up here. Hash map string comma vector, put in a string, and looks like we have a comma for randomness, random state. That's going to be the map. Add a department. We're going to need the sentence, the full sentence. Call it a reference. So call it sentence. And make that a reference to a string. And since we're adding something to the hash map, this has to take ownership of the hash map, but we still need the hash map in the other state, the main function. I mean that encapsulation. So we're going to pass back the hash map. Pass back the hash map, and that is this stuff all over again. Control copy. And note that this hash map is mutable because we are adding something to it. That is a very long signature. And return map. Map. Okay, so we have the basic outline, I think. This is yelling at us. That was just for us to look at. We don't actually need that there. So we have coming into this function, we have a map and we have our sentence. And the sentence is just going to be this regular sentence thing here. Yeah, this line thing, right? So let's write down, here's the add. Let's do the map is going to be equal to add to department, and we're passing in the map, and we're passing in the line. And now here we know what we have. So we have to do the same parsing that we did before, just so we can get each word and figure out what we're going to do with each word. That is this thing right here. Control copy, paste. So for index word in line, did I call it line? I call it sentence here. For parity's sake, let's just call it line. And everything seems to work for line. We're gonna have our word. Let's do that again with word. Underscore word is equal to word dot trim first dot to lower dot to string. And now we're gonna compare it. So we know the sentence structure. Just take this one, right? Control copy. Put it here as just a reminder so we can look at it. Paste. We have our 4 words. We already know the first word is add. So technically speaking, we don't have to look at it. The second word is going to be a name. So if index is equal to 1, that's going to be the second word. We do, where do we want to define the name? Because it's going to be it's going to be defined in a scope. So let mutable name equal that toString. Now you want to say our name is going to be equal to this word, underscore word. And now we have a name. In terms of the 2, we don't care about the 2, but we do care about the next index, which is going to be 3, which is going to be the department name, which we could just take directly. Well, I mean, to be clear, we can say department equal to underscore word, and then say we have a hash map, map dot entry. Wait, why is my map not looking up? Oh, I forgot an if statement here. If. Cool. My map dot entry. Entry is going to be the key. The key is going to be the department. Department dot insert or And here's where it gets interesting, right? Insert or is going to give us a reference to the list, just like we did last time, but let's not refer to last time. This is going to give us a reference to the list, and then here we can do a dot push, I believe, on the name, and then we're returning map there. So what we're trying to do is we come here, we define our name. Name is going to be saved here, just so it exists outside of this scope. And then on the fourth word, which is going to be the department name, we're going to save the department, and then we're going to try to enter that key into the map. And if that key does not exist, we want to return an empty vector. If it does exist, we want to return the current vector with all the other names in it. And then we'll try to push the name onto that vector. And then we're going to return the map. So let's try it out, see what happens. And at the end, for sanity's sake, let's print out this map. Print line. I think it's this, and pass in the map. See, this works. Got an error, 3 errors. The implementation of standard ops mul might be missing for mutable standard vector. Do I not have to? I don't know if that was it. Push not found in the scope. Oh, mutable. Can I say mutable there? This vector has to be mutable because we have to add things to it. So let's create one and then add it to it. Mutable, call it list equal no. Vector? Can I do vector.new? Is that a thing? And then pass that in as default. List. Will that work? List expected vector. I think what I'm missing is a declaration of what this list is supposed to be. That list and this list, I'm overloading it. Let's call this default. Pass in default. And let's define this. And that seems to be fine. Thought it was fine. Oh, push. The name is being moved. Do I want this value or do I want another value? Name dot clone. Let's just clone it. Now you're telling me word has been moved. It was used there. Now it's being used there. When in doubt, I don't know if this is appropriate, but this is what I've been doing. Just loop it. Value borrowed here after move. Name, move there. Where's name? Name's right here. Clone. The reason why I'm cloning it is because cloning it should make a copy of it, a distinct copy, and because it's a distinct copy, I don't have to worry about it being the original copy being moved and used again. So add Marcus, me, to engineering, and as you see, we have a key. This is our map. Marcus, oh, it's right here. It's in engineering. So let's try that again. I can't just do up. Add Joe to engineering. Spell it correctly. Spell it correctly. So now Marcus and Joe are in engineering. And then we can probably do add, I don't know, com to sales. And now we have engineering and we have sales. One thing to note, just because this is the way I went about doing it, everything is lowercase. I'd rather have it lowercase. Actually, technically speaking, we probably shouldn't have those names lowercase. That seems kind of offensive. The name should not be lowercase. The name should not be lowercase. And if that's the case, then name has to be the actual word. Word.trim.clone? I think that might work. So we don't have excess words, but I'm not sure if I can do this. Hold on, let's check. Oh, we can just type exit. That will exit out. And now we have an error. Found a pointer to a string, but wanted something else. Oh, because trim needs a toString. Trim.toString. And that should work. All right. So when we run it, we have our loop. Add M to E. Oh, I was trying to test out whether the name's still capitalized. Add Marcus to E. So now the spelling of the name stays the same, because changing the spelling of the name seems kind of offensive. The department, should the department name stay the same? I would argue so. Departments can be capitalized or lowercase. Changing the department name seems kind of wrong too, so we should probably do the same thing here. And change that to trim, because we don't want anything excess. To string, because we've been using strings. And let's clone it so it can be owned by the hash map. Exit. Try this again. Add to sales. So sales now has a Marcus. That sounds appropriate. So we did the add. The add is done, seemingly. Next, we need to get around to doing the show command. Show. So for the show command, we have two cases, right? We can either, at least the way I described it earlier, we can do show department name. For example, show sales, and it prints out sales. Or we can do the show company, right? Show company, which is going to print out the entire company, but let me just company. So let's get on that. The function should be about the same as add department, with the exception of no, actually should be about the same. With the exception of we're not changing the state of the hash map. So we can copy this for the most part. Control copy. And just bring this back over. Enter. Function. Show. Call it command. Print that out. Do that. Return map. I'm not sure if we need the map there, but we'll find out sooner or later. And let's move this. And we need to do the same thing with words. So We don't need a name, but we do need this for loop. Same basic structure. Control copy. Come down here. Paste. We have the line that's coming in. We're splitting it by white space. We don't care about the first index 0 because that is the show word, which we already defined or seen in the other for loop. We do care about the second index, which is going to either be the department or the company, and we shouldn't get to a fourth index. Word we are defining, and we want to show something. Show, I guess we can just put it here. If underscore word that equals, not in code, equals, technically speaking, if this equals company, then we show everything of the everything in the map. If it does not show company, then we only show a portion of the map. So company dot to string and pointer. Oh, I need this. If it shows this, then print out the entire map. We can just print it out without formatting right now. Map, right? Else, we're just going to print out that department. So for the department, we have the case of whether or not the department exists in this map. In this last example, we wrote Marcus is in sales. If the sales comes through, then we should print out all the people in sales. If a word other than sales comes through, let's say engineering does not exist in this map, we still need to print something out. In that case, you should probably print out an empty list or just say nothing exists. So one thing I think we can do is, our list is already defined? Nah, let list equals map dot entry, take it in the word as the key, or insert an empty list, right? And then we print out this list. So for, I don't know, name and list, print name. Something along these lines. And let's test this out. Get rid of the space. We already have the mapping returned. Show command. You compile. They have a warning here. What does this warning say? There's only one warning. Is it multiple warnings? 2 warnings. This does have to be mutable, and this show command warning dead code on by default. Oh, we never added the lines. Duh. Map. That's why this is dead code. We never added it here. Map. Line. Exit. Do this again. Now we only have 1 warning. Nothing about dead code. I see. Not exactly sure why that's still there. Did I exit? Let me exit again. Run. Okay. Add Marcus to sales. Add Joe to sales. Add Christy to team. 3 different people, 2 different teams. We have a department called team, department called sales, and we have Christy and team, and we have Marcus and Joe in sales. Show sales. That still didn't do anything. Show company. Show company works. Show company works. Sales didn't match. Why didn't sales match? Sales did not match because... Oh, sales did not match because we kept the original word. We kept the uppercase of the word instead of the lowercase version. So if we want to compare it to something, we need to compare it to word. So this brings us to a dilemma. If the department is sales, does it matter if it's capitalized or lowercase? In a case that it does not matter, then both capitalized and lowercase should work. That means we would put this as lowercase, and we would input it sales, the department. Why was I messing with that one? I don't know why I was messing with that one. It should have been here. Entry word sales. This is going to be lowercase because of this thing. It doesn't have to be. If I wanted to, I can just do keyword word dot trim dot to string, and that would work as well. So if we exit, do the same thing, right? Add Marcus to sales, right? So show sales. We now get Marcus. The reason why we get that is because now we're not modifying the string. We now have a capitalized sales, whereas before we're using the lowercase version. And lowercase sales does not equal capitalized sales. They don't equal. So we got an empty vector back. In the case that we want everything to match, whether it's lowercase or capitalized, then we would go back to what we had before, make that word there, right? Underscore word. And then in the add command, when we're adding it, we'll make all the departments lowercase. Department is the fourth word, and this department would be underscore word. Do I have it there? Clone, lowercase, trim. Let me just do a dot, two lowercase, right there. Now, lowercase or capitalized is to work. Run, add Marcus to sales. So sales, Marcus is there. So sales, Marcus is there. I would argue that this is the better behavior, less room for error. So I'm gonna keep it this way, just for me. You can do what I explain both sides. You can do whatever you like, but I like this way more. Exit out. So what we have now is we have our add command, we have our show command, we have a way of exiting. What else is left? So we go back to the question. Using a hash map and vectors, create a text interface to allow a user to yada yada yada, add a department. For example, coming down to this last line, sorted alphabetically. Sorted alphabetically. So there are ways of going about doing this. Sorting it alphabetically means that we can take the vector of the names and sort them before we print them out. So let's go about doing that. That'll be in the show command, right? We have our list. If it is a company, then we have to iterate over everybody and then sort them. So that along those lines is something like, let's do it for the list first. The list is probably easiest. Make that list mutable. And then say list.sort unstable. And then we print out those names. That seems pretty straightforward, at least for this. See if it still runs. It does. So now we can do add. We're gonna add M to sales. Then we're gonna add A to sales. And then we're gonna show sales, right? And we see that even though M was added first, A is first in the line in terms of the output right here. So that's alphabetical order for that. In terms of the company has departments. I don't believe we can sort the departments in alphabetical order, but we can sort the names within the departments. The reason why I say I don't believe we can sort the departments in alphabetical order is because those are the keys of the hash map. And when we're iterating over the hash map, we don't control the order in which the keys are given to us. I might need a different data structure for that, but they instructed me to use hash maps. So I'm using hash maps. So we were lazy earlier. We just said print out the map, right? Now we have to do things like for, well, we have to iterate over the map. How do you iterate over a map? I guess key and value for key, value, in map dot iter. That seems about right. We have a string, we have a vector. Cool. Print line. We're gonna have the department. This is gonna be the key. Then we're going to list dot, oh, it's value. Value is going to be the, I shouldn't say value, I should say list, because it's going to be a list of names. List, can I do list dot sort? It's not liking me. Not exactly sure why it's not liking me, but it's not liking me. So we do something like this, list dot sort, and then that doesn't say mutable. I think there's another iter mutable. Huh, cool. Yeah, there's another iter thing that we can use. You can either iter over things that are static, or we can iter over things that are mutable. Iter mutable seems to work because we need to sort the list, which means the list has to be mutable because we have to move things around in the list. And then we do print, for, same thing we did down here, for name. But this is kind of just duplicate code. We can abstract that a little bit later, but first let's make sure it works. So we'll paste, tab that over, tab that over. We have a lot of spacing. That's one phrasing. Cool, and exit out of this. See how this works? It is running. That's something. So now we already showed that the department side works. Now we need to show that the company side works. So for the company, let's start adding people to company. Add M to, I'll capitalize M. M to sales. Add A to sales. Add B, let's call it Z. Z to team. To team. Add B to team. So the print statement for the debugging is still there, so we can see the entire map. But right now we have two teams, or two departments. One is team and one is sales. And we have ZB in one and we have MA in the other. So now we can do show company. And we see we can get team, BZ, which is alphabetical order, and we have sales, AM. Our teams are not alphabetically ordered. That I think I can get away with saying that was kind of ambiguous. I don't know if it's like doubly sorted but maps, we can't control it. We would have to do something else that's more cumbersome. But that's seemingly what they wanted. We have the ability to use the syntax to add a person into a department. We can retrieve a list of all the people in the department sorted alphabetically, and we can retrieve the list of all the people in the company by department sorted alphabetically. So we've now completed the homework assignment. But this code is kind of ugly and we can refactor some. So that's what I'm going to start doing now.